All right, so the last talk of the session is asking clarifying questions in open domain information seeking conversations.
Hello, good afternoon. I am Mohammed from Università della Svizzera Italiana. I'm here to present our work in collaboration with the University of Massachusetts on asking clarifying questions in open domain information seeking conversations. First, I will try to motivate the problem a little bit, but it's going to be hard after the very nice introduction that Bruce provided yesterday on similar topics. Anyway, I'm going to try my best. So let's assume we have a user called Alice who issues this query dinosaur on a web search. And here's the search result list that she would observe. As we see and we know, this page consists of several components. The first one that gets my attention is the information card that Google generates automatically. Then we also have multimodal information, for example, some news about some dinosaurs, and also we have some videos, apparently. And here we see some similar questions that people have asked in some communities or anywhere that Google provides to people. In the end, we see some similar searches, some query suggestions, apart from all the result snippets that we also see and we are used to that. So assume that our user Alice doesn't find her desired information in this page. Among the different options, one option is to reformulate her query to be more fine-grained towards what she needs. In this case, she's looking for something on Discovery Channel about dinosaurs, and she reformulates it in this way. There we are. She gets the right thing as the first result. As we saw in this scenario, we have a kind of interaction between the user and the system where the user sees multimodal information, and then when she fails to find the relevant information, she tries to improve her query based on the results that she saw. But how we can replicate this scenario in a conversation where in most cases we have only voice channel, so we cannot provide all that information on one screen or even on multiple turns. The question is that, can we ask questions to clarify the user information need? And we have the answer in relevant works. For example, there was a work last year that did a user study on where people could ask clarifying questions, answer the clarifying questions provided by the system. And people found it very useful and enjoyable to have this conversation with the system. Also, another work that was presented at CHEER 2017 by Rodlinsky argued the same issue, that the system needs to interact with the users in order to clarify many types of queries. And here is what we present here. Basically, this is the scenario that we are looking for. Assume that we have two users here. We have Alice and the other user who issue exactly the same query to the system, but their actual information need differs completely. While Alice is looking for something on Discovery Channel, Robin is looking for some list of dinosaurs. And we see that this is let's say, a sample conversation that we have with the user. The system would start with the same question if there is no prior information about the context or anything. And, but the most important thing is that with the answers that we get from the users, the conversation is driven to the point to narrow down the information need of the user to the point that the system is confident enough to present the results. Here we provide a sample workflow of such a system, which we are going to discuss here. As we said, Alice submits her query to the system, and then system retrieves a list of results. And here we assess the confidence of the system in the returned results. As we see present results, yes or no. Let's assume the system is not confident enough, so we go to the next phase where the system should be able to generate some questions based on the information need of the user, based on the query, sorry. And then at the next step, the system should be able to select only one question to ask to the user. As we know, system question generation can generate multiple questions, but it is important to select only one that would maximize the precision at this point. Then the question is passed to the user, and the user would provide us with an answer, and the same process goes on. The new documents are retrieved, considering both the query, the question, and the answer. And we assume here that the system is now confident about the results, and in the end, we are able to present the results to the user. But the most important challenge is to know how to evaluate such a system without needing users to interact with the system, basically how to have an offline evaluation. What we did in this work, we tried to reuse the data from Qulac Web collection that was a part of the Lemur project, consisting of over 50 million documents, and it was used in TREC Web Track from 2009 to 12, and it consisted of 200 topics with an average number of 3.85 facets per topic. The facets were designed to evaluate systems in terms of diversity. As we see here, this is an example of the same query in the collection. This query came with 3 different facets: Discovery Channel, dinosaur pictures, and dinosaur books. And these are the relevance assessments provided by TREC. As we can see, the relevance assessments were at the level of facets. So we knew that each topic is relevant to which one of the facets. What we did here, we assumed that each user is interested in only one of the facets, and the system should try to understand what is the facet that our current user is interested in. For example, we see that as we saw, Alice is interested in Discovery Channel. These are the relevant topics only to Discovery Channel, and Robin, the dinosaur pictures. We also have Roskiller, who is interested in dinosaur books. So formally, how we can make an evaluation framework? As we discussed, we have a set of topics which we borrow from Qulac Web collection. We have a set of facets for each topic, on average 3.85. And then we have to collect questions for each topic and facet pair. How we collect sample questions here? We try crowdsourcing. So in the crowdsourcing, we try to introduce the task to the users. They are not familiar with anything that we say, so we provided a very simple example and try to tell them, okay, assume that such a system exists, and tries to ask clarifying questions. And then we didn't give them the facets. We asked them, you have to try to figure out the facets of the same query. Assume you are Google and you want to ask the same question to the user. We provided them with some examples and also some tips on how they can do it. They could look at the result list, or they could look at the query suggestions, auto-completions by Google, and they were providing us with some questions. In the next step, we went through the questions to ensure the precision. So we wanted to have high-quality questions, but also recall. We wanted to cover all the facets. So we had some expert annotators who went through all the questions to make sure that they address all different facets, and in case they realize that some facets require more detailed or more specific questions, they could also write new questions. So that we were sure we are addressing all the facets in our sample set of questions. The final part of our framework is a function that is able to take a topic, one of its facets, a sample question, and is able to provide the answer. That is the key to having an offline evaluation framework. As we have all the sample questions, candidate questions here, we are able to set up another crowdsourcing task where we give the topic, we give the facet or information need, and then we give the questions and ask the users to assume this is their real scenario where they are trying to do this, and they provide us with answers here. To check the quality of the answers, we checked 10% of the answers provided by each user, and then we went through the users that were not providing us very good results. More details are in the paper. And we call our dataset Qulac, which stands for questions for lack of clarity. Qulac happens to have two meanings in my language, Persian. One meaning is blizzard, and the other one is wonderful or masterpiece, which I think is the case with this Qulac. So you see some statistics of the data. I won't go through them. You can find them in the paper. But let's go through some experiments that we did on the data to make sure that the quality is good, and also to have some insights to this problem. One thing that you might have noticed so far is that in the original proposed workflow, we don't have any question generation part. That is because we are trying to have it as an offline system. Therefore, we make it question retrieval. So we have assumed we have a big, very large bank of questions for the collection. So in this scenario, we are trying to retrieve the relevant questions to the query so that we have a list of, I don't know, top 50 questions, so that the system is able to afterwards pick only one to maximize the precision. So for question retrieval, as we said, high recall is desired because we want to have top 50, top 100 questions from the whole collection of bank of questions. But we want to make sure that we retrieve all relevant questions. We tried some classical IR approaches as well as some learning to rank and a neural model based on BERT. And we see that BERT, which we call it BERT liquor, is able to outperform everything for obvious reasons. And here we have a diagram of our model. So then we move to question selection part, which we also try to study. So as we said, the question selection component takes the top K questions that were retrieved by the question retrieval and picks only one to optimize the precision. We did some query performance prediction and learning to rank approaches. We also studied a neural approach, which is based on some features from QPP and some features from the representation, which is also, again, based on BERT. But we also analyzed two other models that you see in the bottom. These two models are the Oracle models, so where we pick the best question every time based on the evaluation and the worst question. So this is to give an idea first of the upper bound and lower bound, but we were also interested to see, assuming that we have a perfect system, what is the maximum gain that we can get from the question and other analysis, which we will see later. But the important take here is that we saw that asking only one good question, best question, leads to over 100% relative improvement in some cases, in some, for example, metrics like precision at 1 or NDCG at 1, it was over 170, which indicates that this is an important part of a conversational system with potentially very high impact. Then we see other selection models, and not surprisingly, we see that the Nukes model, which is based on BERT and other features, outperformed the others. Later, so the data, to clarify, the data is single-turn, but we wanted to study some multi-turn setting. That is why we artificially generated some multi-turn conversation with having all possible combinations of questions and answers. We saw that even in this case, we see that multiple turns improve the performance. And here we have some more experiments on the Oracle model. As we see here, we see that query terms, so shorter queries are, so this diagram shows the improvement after asking questions. With respect to the number of query terms, we see that shorter queries improve better. So it's not surprising, because generally shorter queries are, can be more ambiguous. We also studied the topic type, where we had faceted and ambiguous type based on the classification of TREC Web Track. And we saw that ambiguous queries benefited more from clarifying questions. We also checked the type of facet, navigational, informational, again based on TREC. We saw a little bit of improvement more for informational topics, facets. Finally, we have a case study, which I don't go through all of it. You can find more details in the paper, but it is interesting to see when the model fails, the upper part of the table. We see a typical example where the question is a yes and no question. The answer is no, but the user is providing us with additional information that can potentially be very useful. However, the system here fails to incorporate that information. We have to admit that the document retrieval model that we used was very simple and was not able to incorporate this additional information. And we see a typical, very good example where the system gains a lot. And this is where the system is able to ask open questions. We realize that open questions are very hard and very rare in the collection, but they are very rewarding. You kind of prompt the user to provide additional information. This work, we believe that open various future directions. One is to, as we saw in the example, it's very important to also use positive and negative feedback from the user in the document retrieval. So there is a lot of room for improvement there. Also, it would be interesting to study question retrieval and selection, joint modeling of them, while having them as two separate components. Question generation is also a very interesting direction that can be taken, but it would be very challenging because of, it's difficult to evaluate it offline, and you're going to need a lot of data. Also, we didn't discuss how we can determine the confidence of the system after asking each question so that the system can decide when to stop and present the results. This can be studied in the future, and also we can have more realistic conversation, multi-turn conversations where you can study the conversation turns and also the retrieval performance in many different scenarios. To conclude, we saw that the performance of the Oracle model on our data set is improved by over 100% with asking only one clarifying question, good one. So this clearly shows that this is an important task, and we saw that shorter and ambiguous queries are generally more benefited from this task. And in the end, I would like to thank you for your attention, and thanks to SIGA-YAR for the travel grant. I'm here for questions.
We have time for one quick question, and then the coffee breaks outside. So,
Thank you. Thanks for the talk. So I would like to ask about the BERT. Did you use the pre-trained BERT, and did you do the fine-tuning one or not?
For retrieval, we fine-tuned BERT, but for selection, we only use the representations.
Oh, so you like keep them fixed?
For question selection, yes, but for question retrieval, we fine-tuned.
Yeah, and which configuration you use?
For question, we use the standard one, not the large one, and uncased.
all right, we could thank the speaker again.
I forgot to say that the data is publicly available.
The coffee break is right now, so I'm sure you can catch the speaker at front for any more questions.